There it is.
Okay.
Strontium hydroxide. All right, I'm going to try and make my charge box smaller.
Okay.
I'll do it up over here.
Good plan.
I need some space.
All right. Strontium is Sr with +2 charge.
So we have Sr plus 2.
Yep.
Hydroxide is OH -1. Back of my periodic table or whatever you got to.
Chloric acid.
Chloric acid. So if it's an ic acid, it came from an 8.
8.
So this would be hydrogen.
Because all acids start with hydrogen.
Hydrogen chlorate.
Chlorate. So
And chlorate
ClO3
is ClO3
with a -1 charge.
with a -1 charge.
Okay. Yeah, the acid, guys, tells us that it has a hydrogen ion in it. That's where the hydrogen came from.
Yeah, the word acid means H positive, not H, but H positive. All right, so strontium hydroxide would be SrOH2 plus HClO3.
Yep. Both of those are aqueous. You could look them up.
Yeah.
But we're going to
You can use our chart, trust us, and you'll have to use the chart, sadly.
Yeah,
But
we're
we
gonna save you
have
some
it
time.
memorized. All right, now we're going to now change partners. So the strontium is going to get together with the chlorate. That's +2, -1. So SrClO3 2, and I happen to know that also is aqueous.
Look it up on the table if you don't believe us.
Plus, H is going to get together with OH, so that'll be HOH. Now, let's look that one up on the chart, though,
Yeah,
Mr. Sams.
okay.
I think that would be important.
Good idea.
So if we find hydrogen, here it is, hydrogen hydroxide, it's water.
Hydrogen hydroxide is water.
So that counts as a, well, it's a liquid,
Yep.
right, guys? So
Yeah.
we're talking about a liquid substance right here. So this is your liquid. So that proves the reaction occurs.
Right, because a solid or a liquid formed, it
Yeah.
goes.
Now let's see if we can balance this.
Okay.
Probably this is my most complex, though it's not that complex. I've got 2 chlorates, so I'm going to put a 2 in front here. And that gives me 2 hydrogens. I got
4
one.
hydrogens.
No, it's just 2.
Oh,
There's
you did
2
you treated
hydrogens.
the hydroxide
Yeah.
the same? Okay, I get
There's
it.
2 hydrogens, and actually, so I've only got 1 hydrogen. Think of hydrogen or water as HOH. So if I put a 2 here, there's 2 hydrogens, and then I then have 2 hydroxides. So that's actually the balanced equation.
Yep, there it is.
So this is the molecular equation. Call it the Me. Now let's do the ionic equation. Now in the ionic equation, you will split everything up except for
Water.
water.
Right,
I say
anything
solids
solid or a liquid.
liquids, and we have a liquid here. So everyone gets split up. So strontium. So I'm going to split the strontium hydroxide up. So I'm going to write Sr plus 2 aqueous plus hydroxide aqueous. Now notice about the 2. You say, Mr. Bergmann, you deal with the 2 here. I write the hydroxide as appears in the charge
Yep.
box. The 2 then comes out
To the
in
front.
the front. Plus H positive AQ. Now we've got to, let me write it out. Plus ClO3 negative AQ. Now what do I do with this 2? This 2 multiplies everything.
Everything. So there's 2 hydrogen ions and 2 chlorate ions.
Perfect. And now this is an aqueous, so I'm going to split that up. So there'll be Sr plus 2 aqueous plus 2 ClO3 negative AQ. All right, that's because of this 2 right here. Plus 2, and I'll just say H2O if I want to. Liquid. That's the ionic equation.
Yep.
Done.
Or the complete ionic
Or
equation.
the complete ionic equation. Is there anything that's exactly the same on both sides?
There is.
What would that mean, Mr.
Strontium ions.
So the strontium is the same here and here.
They're both strontium ions aqueous.
So they're going to cancel.
Yep. And the chlorate ions. 2 chlorates, 2 chlorates, they go away.
So the net ionic reaction will be 2 hydroxides, AQ, plus 2 hydrogens, AQ, make 2 waters, liquid.
Can I get rid of all those 2s since they're all 2s?
Yeah, you could actually say, you could round down.
Just do
or
1 to 1 to
reduce
1.
the fraction,
Yeah.
if you will. Yeah, it works too. But that's how you would do it.
All right.
All right, let's do one more example.
Okay.
All right. Let's make it up. Let's do one more, Mr. Sams.
Okay.
All right, this is kind of a nasty one, but that's all right. All right, first thing, start with the charge box, right?
Yep.
So I've got potassium phosphate.
Alrighty.
So
Let's do it.
in my box, put it over here. Potassium is K with a charge of positive
Plus
1. Phosphate is PO4, negative 3.
Okay.
And then the second chemical is mercury 2 nitrate. Now, what's that Roman numeral mean?
The charge, I
So
believe we've decided.
Hg plus 2, and
Yes.
then nitrate is NO3, negative 1.
Okay.
So let's put them all together.
All right. Potassium phosphate.
K3PO4.
Uh-huh.
Now, if you look at the solubility table, trust me, Mr. Bergmann, oops, it's AQ, right?
Yep.
And mercury 2 nitrate would be HgNO3 2. That is also aqueous.
Don't believe us? Check the table.
You can check the table. And that's
or you
going
can
to
just
trade
do
the partners. Potassium's going to get together with nitrate. That's easy.
Okay.
1 and 1.
Yep.
That'll be just KNO3. And that's also aqueous.
Aqueous.
And here comes our solid. If we put the mercury, 3 and 2.
Yep. Make them 6.
Make them 6. So that'll be Hg3 parentheses PO4
2.
2. That should be an O. All right.
Mercury phosphate.
And that is a solid. I don't think I want to mess with mercury.
No, that sounds kind of nasty.
All right, that's my most complex one, right?
Okay,
so
yep.
I'm going to put a 1 there, and let's do the mercury. I've got
Balance,
3 of them over
yeah.
here, so I can put a 3 there. I've got 2 phosphates, so if I put a 2 here, that gives me 6 potassiums, so I put a 6 here. That gives me 6 nitrates. Hey, looky there.
Hey, look at that. There's 6.
So that's our complete equation.
Yep.
All right, now the net ionic. Okay, this is going to be a bear. Break up your AQs. That's this one, this one, this one, but do not break up your solid.
Nope.
So to break this up, now watch how I do this. I'm going to say K positive. Now, how many Ks do I have?
2 times 3.
I have 6. So there's 6 K positive. You know what? Yeah, all right, AQ. Plus, this 2 multiplies the phosphate, so I'll say
2 phosphates.
2 phosphates. 2 PO4 negative 3 AQ plus, all right, I'm going to break this up. I see the 3 in front, so that's going to multiply everything by 3. So 3 mercuries, so 3 Hgs. Now I have to write the charge like I have over
Plus
here.
2.
Plus 2. Plus
2 times 3 is
6
6 nitrates. The 3 in the front and the 2 at the end applied to the nitrate.
All right. So we've got the products done, or the reactants.
Reactants.
Let's do the products.
Okay.
Now this one is an AQ, so I'm going to split
Yep.
it apart. And there's a 6.
6
So
potassiums.
6 potassiums. I still must put the charge in the little AQ here. Plus 6 nitrates. AQ.
Okay.
And then we have just one more thing left. Now, what do I do with this?
Leave together. It's solid.
Why?
Because
So
it's a
just
solid.
Hg3 PO4 2 solid.
Okay.
That is your
Complete ionic equation.
complete ionic equation. CIE. Yeah.
Kind of like pi, but without a p.
There you go, psi. Now what we need to do is we need to
Get
find
rid of
any
the spectators.
Who is exactly the
I
same on
see
both sides.
6 potassiums on the left and 6 potassiums on the right.
All right, so the potassium can cancel. Potassium here, potassium here. Good, okay. Anything else you see, Mr.
I see some nitrates. 6 of them on the left and 6 of them on the right.
Okay, so now to write the net ionic equation.
Oops. Oh no.
You gotta be kidding me. Okay, Mr. Bergmann just accidentally hit the erase all button, but we can do this from our head.
Yes.
What did we
We
have?
had the mercury 2 ion left.
So we're going to have, didn't we have the phosphate
there were-
first?
yes, we did have phosphate
So there'll
first.
be,
one
how many?
phosphate.
No, there's more
No,
than one
you're right.
phosphate.
There were 2 phosphates,
It's going to be PO4, negative 3, AQ.
and there were 2 of them.
And there were 2 of them, plus 3, HG plus 2,
Yes.
AQ, makes
Hg3,
HG3,
PO4.
PO4, 2 solid. So that's the final answer.
Yep.
Just back it up to see where we were canceling because
Yeah.
I accidentally hit the erase
We
button.
canceled all the spectators.
And we're
Whatever
trying
was
to do
left,
it-
we rewrote
this-
as that.
This is what's left because all the potassiums and the nitrates, they all canceled out, which you just saw. So that's how you do net ionic type equations. Hard stuff, but once you get it, it's not that
doable.
hard. It's
Yeah.
just it's tedious, no
It is.
question. But
And the guys, the key here though is just knowing how to write chemical names and formulas using the little charge box, your scratch
just
pad.
use the charge
Use the
box.
scratch pad.
This must be used. Use me.
Yes.
All right.